We've seen a lot of issues with these active grille shutters, not just on this vehicle, on a ton of vehicles. I don't know what it is. We just see these things failing and taking down the bus that they're on.
Some trucks don't just break down. They break the mechanic working on them. Hidden under the hood are engines so unreliable, systems so badly engineered, and repair jobs so painful that many shops simply say, "Nope, take it somewhere else." Today, we're exposing the trucks that professionals avoid at all costs, the nightmares that turn routine fixes into full-blown disasters. If you think all trucks are built tough, wait until you see the ones even mechanics refuse to touch. Let's begin. Number 10. Ford Powerstroke 6.0-liter F250/F350. Mechanics have a nickname for the 6.0-liter Powerstroke, and it isn't flattering. This engine became infamous for problems that stack on top of each other, turning even routine repairs into massive, time-draining jobs. Shops know that if a 6.0 rolls into the bay, it's rarely just one problem. It usually comes with a chain reaction of failures waiting to explode, and no mechanic wants to lose an entire day, or more, fighting this thing. One of the biggest reasons mechanics refuse these trucks is the EGR system, which is arguably one of the worst ever put on a diesel. The cooler loves to crack, clog, and push coolant into places it doesn't belong. When that happens, you're not just replacing a part. You're chasing overheating, smoking, stalling, and sometimes full engine failure. It's a mess. Then there are the head gaskets. Ford used weak head bolts on this engine, and the massive pressures inside a turbo diesel easily stretch them. That means blown gaskets, coolant puking out of the Dega bottle, and repairs that require removing the cab on many models. Yes, you heard that right. Mechanics often have to lift the entire truck body off the frame just to get proper access. The injectors also love to fail, thanks to high-pressure oil systems that are sensitive to even minor issues. A failing HPOP, STC fitting problems, or low oil quality can turn the injectors into a multi-thousand-dollar headache. And if you fix the injectors, the turbo might be next. The variable geometry turbo clogs with soot so often that many shops simply stopped agreeing to clean or rebuild them. It's not that mechanics can't fix these trucks. They can. It's that the time, complexity, and cascading failures make them terrible business. One job becomes 4, labor hours explode, and both the customer and the shop end up frustrated. That's why when a 6.0 Powerstroke pulls in, many mechanics look at it, sigh, and politely suggest you take it somewhere else. It's simply not worth the fight. Number 9. Dodge Ram 1500 2004 to 2007 4.7-liter. This generation of the Ram 1500, equipped with the 4.7-liter engine, is a textbook example of how a powertrain can look fine on paper, but become a total nightmare in real-world ownership. Mechanics don't avoid these trucks because they're impossible to repair. They avoid them because every repair seems to lead to 2 more problems hiding behind it. It's the kind of engine that turns a simple job into a weekend-long fight with bolts, sludge, and overheating issues. The biggest problem with the 4.7-liter is sludge buildup. These engines run hot by design, and if the owner wasn't extremely consistent with oil changes, thick tar-like sludge forms in the heads and oil passages. When a mechanic opens one up and sees that mess, they know they're about to spend hours cleaning, scraping, flushing, and hoping the engine survives the repair. Sludge is unpredictable. It can hide failing lifters, clogged passages, or weakened bearings. No shop wants to guarantee work on a motor that might give up 2 weeks later. Then you have the notorious overheating issues. The cooling system on these trucks must be 100% healthy at all times, because the engine doesn't tolerate heat spikes. Radiators, water pumps, thermostats, and intake gaskets all fail more often than they should. And when these trucks overheat, they don't just get hot. They drop valve seats, which can instantly destroy the engine. Mechanics hate this, because even after fixing the overheating issue, the internal damage may already be done. Electrical problems pile on as well. These Ram trucks from the mid-2000s are known for failing TIPM modules, dash cluster issues, random sensor failures, and wiring harness problems. A truck that won't start or keeps throwing mystery codes becomes a guessing game, and mechanics prefer avoiding vehicles that require hours of diagnostic work before the real repair even begins. Even simple access is difficult. Spark plugs sit in cramped areas, and intake removal is often required for repairs other brands let you do in minutes. It's never just a quick fix. Everything takes longer. So when a mechanic sees a 4.7-liter Ram roll in, the reaction is usually the same: frustration. Not because they can't fix it, but because this engine is unpredictable, overly sensitive, and likely to fail again, even after proper repairs. That's why so many shops turn these trucks away before the hood even goes up. Number 8. Chevy Silverado 1500 AFM engines. If there's one modern truck engine that mechanics wish never existed, it's the GM V8s with active fuel management, AFM. These engines were designed to shut off half the cylinders to save fuel, but in real-world use, AFM became one of the most notorious failure systems in truck history. Mechanics don't avoid these trucks because they're complicated. They avoid them because AFM failures snowball into massive, unpredictable repairs that can cost owners thousands. The biggest issue is the lifter collapse problem. AFM relies on special lifters that switch between active and deactivated modes. But when these lifters fail, and they fail a lot, they collapse, seize, or destroy the camshaft. A mechanic knows that if one lifter fails, the others aren't far behind, and repairing the problem means tearing deep into the engine, removing the heads, replacing the lifters, possibly replacing the cam, and hoping the metal shavings didn't spread everywhere. Even worse, many owners ignore early symptoms like ticking or misfires because the truck still runs. By the time it reaches a shop, the damage may already be extensive. No mechanic wants to risk rebuilding a top end on an engine that may still fail again later due to bottom-end wear. Then there's the oil consumption issue. AFM engines are known to burn oil at alarming rates. The PCV system pulls oil mist into the intake. The rings wear prematurely, and the excessive oil burn can foul plugs, damage catalytic converters, and create misfires that are hard to diagnose. Shops hate working on engines where the real cause of the problem might be hidden deep inside worn piston rings. The AFM system also creates constant check engine lights, misfires, cam, crank correlation codes, O2 sensor faults, and random stalling all become part of the AFM bingo card. Mechanics end up spending hours diagnosing issues that trace back to the same flawed system. It's not efficient, and it's not profitable. And let's talk access. The way the engine is designed means that a simple fix, like replacing a lifter, becomes an intense multi-hour job involving upper engine teardown. Many independent mechanics simply don't want to take that risk, because once you open an AFM engine, the customer's wallet and your reputation is on the line. That's why many mechanics outright refuse to work on AFM-equipped Silverados. They know that even if they fix the immediate issue, AFM creates a long list of problems waiting to happen. These engines don't just fail, they keep failing, and that's a recipe most shops want no part of. Number 7. Nissan Titan, first generation 5.6-liter V8. The first generation Nissan Titan had big power and bold styling, but under the surface, it carried some of the most frustrating mechanical problems any truck mechanic could face. Shops don't avoid these trucks because they're weak. They avoid them because everything that goes wrong is both expensive and unnecessarily difficult to access. What should be simple becomes complicated, and what should be routine becomes an all-day ordeal. One of the worst problems on early Titans is the rear differential failure. These diffs were notoriously underbuilt, especially for trucks used for towing or hauling. Mechanics know that when a Titan shows up making whining or grinding noises from the rear, there's a good chance the differential is already toast. Rebuilding them is time-consuming, sourcing parts is a hassle, and replacing the whole assembly is expensive for owners, often more than the truck is worth. Many shops simply don't want to take responsibility for a repair that has a high chance of coming back. Then there's the brake system, which was so problematic that Nissan issued multiple fixes over the years. The rotors warped easily, the calipers seized, and the trucks frequently shook violently under braking. Mechanics don't mind replacing brakes, but replacing them over and over again because the underlying design was flawed? That's something shops absolutely hate. It creates unhappy customers and endless comebacks. So many mechanics avoid Titans just to skip the drama. The exhaust manifold cracking issue is another headache. These engines love to develop manifold leaks, which cause loud ticking, lost power, and failed emissions tests. Repairs require removing rusted bolts, fighting tight spaces, and praying nothing snaps off in the head. It's one of those jobs where a mechanic has to charge high labor, work in miserable conditions, and still hope the job doesn't turn into a nightmare halfway through. Even simple repairs become strangely difficult. The engine bay is packed tight, wiring harnesses run through awkward places, and components are stacked on top of each other. Something as basic as swapping spark plugs or replacing a starter can take far longer than comparable trucks from Toyota, Ford, or GM. Electrical issues also plague this generation. Faulty fuel gauges, sensor failures, door lock actuators, and random warning lights that send owners to multiple shops searching for the root cause. Mechanics don't like guessing games, and Titans often turn into exactly that. So when an older Titan rolls into a shop, many mechanics quietly hope it keeps rolling right back out. The parts are expensive, the repairs are tedious, the failures are repetitive, and the likelihood of things going wrong during a repair is simply too high. That's why many shops choose to avoid this truck entirely. Number 6. Ford Explorer Sport Track V8 models. The Ford Explorer Sport Track seems harmless at first glance, a mid-sized truck with decent power and everyday usability. But mechanics who've spent time under the hood know that these trucks can turn even simple repairs into multi-hour marathons. The V8 versions in particular come with design quirks, aging components, and layout choices that make shops think twice before accepting one. The biggest issue is the timing chain setup, especially on the older V8 models, and even worse on the V6 versions. These engines use complex timing chain systems with guides and tensioners placed at the rear of the engine. When they begin to fail, and they absolutely do, the repair requires removing the entire engine or transmission. No mechanic enjoys explaining to a customer that a timing chain job is going to cost more than the truck's value. Shops hate these jobs because the labor is enormous, and any small mistake can lead to catastrophic failure. Another major headache is the transmission. The 5 R55 series transmissions used in these trucks are infamous for slipping, hard shifting, solenoid failures, and overdrive problems. Diagnosing these issues is a time sink, and rebuilding them can lead to repeat visits even when the repair was done correctly. Mechanics don't want to deal with transmissions that have a reputation for coming back with new symptoms each time. Then there's the cooling system, which is loaded with plastic components that age poorly. Thermostat housings crack, radiators leak, heater control valves fail, and water pumps give up earlier than expected. A truck that overheats once may end up needing multiple cooling system components replaced just to stay reliable. Shops know that this often leads to chain reaction repairs customers don't want to pay for. Even basic accessibility is terrible. The engine bay is cramped, especially on the V8 models where Ford squeezed components into tight spaces. A simple alternator replacement can turn into a puzzle. Coil packs sit in awkward positions. Reaching the rear spark plugs becomes a knuckle-busting test of patience. Mechanics hate vehicles where easy jobs become long, annoying, unprofitable tasks. Electrical gremlins also plague these trucks. Faulty blend doors, dead instrument clusters, malfunctioning power windows, random ABS lights, and sensor failures can send owners on a tour of different shops. Mechanics generally avoid trucks with unpredictable electrical behavior because diagnosing them eats up hours and doesn't guarantee a fix. The Sport Trac isn't the worst truck ever made, but it's one of the most frustrating. Every repair takes longer than expected. Every failure seems tied to something deeper, and every job carries the risk of uncovering another expensive issue. That's why many mechanics prefer to steer clear of these trucks entirely. Number 5. Ram 2500 and 3500, 6.7-liter Cummins with emissions equipment. The 6.7-liter Cummins itself is a strong engine. Mechanics don't hate the motor. What they hate is everything bolted onto it. Once emissions equipment became mandatory, this truck turned into a shop's worst enemy, not because the engine fails, but because the emissions systems fail constantly and create massive, expensive, technician-draining repair jobs. Many independent mechanics don't even have the tools or the time to touch these trucks. The biggest headache is the DPF, diesel particulate filter. The DPF clogs if the truck isn't driven long enough to regenerate properly. When it fills up, back pressure skyrockets, and the truck goes into limp mode. Cleaning or replacing the DPF is a nightmare for shops. Removal is labor-heavy, new filters are extremely expensive, and owners are rarely happy when they hear the bill. Mechanics also know that a clogged DPF can trigger a chain of failures, including sensors, turbo issues, and EGR problems. Next is the EGR, exhaust gas recirculation system, which dumps soot back into the intake over time. Everything from the intake manifold to the valves gets coated in thick carbon sludge. Cleaning that mess takes hours, And many trucks run terribly even after a repair because the buildup returns quickly. Add in the EGR cooler, which loves to crack or plug, and you have a recipe for coolant loss, smoke, overheating, and hard-to-diagnose rough running. But the real reason mechanics refuse these trucks? The turbo actuator. This electronic actuator controls the variable geometry turbo vanes. When it fails, and it fails a lot, the truck loses boost, power drops, the check engine light starts flashing, and the truck usually derates. Replacing the actuator requires calibration tools that many small shops don't own. If the turbo itself is also stuck or damaged, the repair becomes a multi-thousand-dollar job. Mechanics know that even after replacing the actuator, more emissions problems are likely waiting right behind it. Then there's the NOx sensors, DEF heaters, pressure sensors, and temperature probes, all placed in tight, hot locations where they seize, rust, or snap off. Replacing one sensor can turn into extracting broken bolts, dropping exhaust sections, and fighting with components that were never designed for easy service shops. Hate repairs that eat up hours just to fix a single bad sensor. Even routine tasks are complicated. The engine bay is packed tight, and emissions components block access to many standard service points. A job that should take an hour on an older Cummins can take several hours on the 6.7 because you need to remove multiple parts first. And if something goes wrong again, which happens often, the customer blames the shop, even though the real problem is the design itself. That's a major reason many mechanics refuse these trucks. The risk of repeat issues is too high. The 6.7-liter Cummins is powerful, reliable, and long-lasting, until the emissions system starts acting up. When it does, mechanics know they're stepping into a minefield of expensive parts, angry customers, and tedious labor. That's why many shops simply say, "We don't work on these anymore." Number 4. Toyota Tundra 5.7-liter air injection pump models. Toyota has a reputation for building bulletproof trucks, and for the most part, that reputation is well earned. But even Toyota stumbled with the 5.7-liter Tundra, equipped with the infamous air injection pump system. A system so badly designed and so outrageously expensive to fix that many mechanics refuse to touch these trucks. It's not that the whole truck is unreliable, it's that one specific system can turn a perfectly good engine into a mechanical nightmare. The air injection system was designed to reduce cold start emissions by pumping fresh air into the exhaust. In theory, it's simple. In reality, Toyota buried the air pump and valves deep inside the engine bay, in one of the most inaccessible and heat-soaked areas possible. That means when the system fails, and it will fail, it usually takes the mechanic hours of labor before they can even see the components. The biggest issue comes from water intrusion. Moisture gets sucked into the air pump and into the switching valves, causing them to corrode, seize up, or break entirely. When that happens, the system triggers a check engine light and forces the truck into limp mode. That's when owners go to the shop and hear the bad news. The repair can be shockingly expensive. Mechanics hate this job for one simple reason. The parts are extremely costly, and the labor is brutal. Replacing the air pump and valves can require removing the intake manifold and multiple surrounding components. An hours-long disassembly process that eats up time and leaves no room for error. And because the parts fail due to corrosion, bolts often snap, gaskets tear, and connections break. Shops know that any air pump job on a Tundra can turn into a much bigger, more stressful repair. Making things worse, when the valves stick open, they can allow hot exhaust gases to travel backward into the air pump system, melting plastic components and destroying wiring. A repair that should have been 1 or 2 parts suddenly becomes an air pump. Both switching valves, hoses, wiring, and sometimes additional sensors. Mechanics also dislike the unpredictability. A Tundra may come in with an air pump code, but once the system is opened, there's no telling how much damage lies inside. Shops don't want to quote a price, only to discover the truck needs triple the parts once everything is torn apart. To add to the headache, some Tundra owners try installing bypass kits or block plates themselves, which can create even more diagnostic confusion. A mechanic never wants to untangle DIY fixes, especially on a system already notorious for trouble. Everything else about the 5.7-liter Tundra is practically bomb-proof. The engine lasts forever, the transmission is reliable, and the truck as a whole is tough. But that air injection pump system, it's so badly placed, so expensive, and so prone to failure that many mechanics just refuse the job altogether. They'd rather avoid the stress than spend hours fighting a design Toyota should have never approved. Number 3, Chevy Colorado and GMC Canyon, 2.8-liter Duramax diesel. On paper, the 2.8-liter Duramax in the Colorado and Canyon looks like a dream. Great fuel economy, solid towing for its size, and diesel torque in a mid-sized truck. But mechanics quickly discovered that working on this engine is far from a dream. It's more like stepping into a maze of sensors, emissions components, tight engine packaging, and electronics that only dealership-level tools can fully communicate with. That's why so many independent shops refuse these trucks altogether. The number one issue mechanics complain about is the emissions system, which is far too delicate for real-world use. The EGR valve, EGR cooler, DPF, DF system, and its multiple NOx sensors all play a part in making these trucks a constant check engine light machine. The DPF gets clogged easily, especially on trucks that spend time idling or driving short distances. Once it clogs, regeneration doesn't work properly. Back pressure rises, and suddenly the truck is in limp mode, with a dozen codes popping up at once. Shops hate this because fixing one component often reveals that 3 others also need attention. Then you have the turbocharger issues. The variable geometry turbo on the 2.8-liter Duramax is small and works hard. It doesn't take much to throw it off. Excessive soot, sticking vanes, or actuator failures can leave the truck with poor power, smoke, and inconsistent boost. Replacing the turbo or actuator requires precision, programming, and sometimes specialized scanners that smaller mechanics simply don't have. And even when they do, parts availability can be slow and expensive. The injectors create their own set of problems. They must be coded precisely into the truck's computer after replacement. If the coding fails or the shop doesn't have the right tool, the truck will misfire, idle rough, or throw multiple fuel-related codes. Shops prefer engines where replacing an injector doesn't feel like defusing a bomb. Access under the hood is another nightmare. The 2.8-liter Duramax is tightly packed inside a mid-size frame, which means everything is layered awkwardly. Replacing something as simple as a thermostat or a sensor often means removing multiple components just to reach it. For mechanics, time is money, and Colorado Canyon diesels turn every job into a long, tedious process. Electrical complexity is another reason many shops refuse these trucks. The wiring harnesses run tightly against heat sources. leading to insulation wear, shorts, and sensor failures. When that happens, diagnosing the problem becomes a multi-hour hunt through connectors, modules, and loom sections. Mechanics don't want to spend half a day tracing wires for a job that pays for 1 hour of labor. And let's not forget the DEF system, which introduces its own problems. Failed heaters, crystallized urea, pump issues, or contaminated DEF can trigger warning lights and limp mode. Once again, repairs require dealership-level tools to reset and calibrate the system. Independent mechanics generally avoid vehicles that force them into tool limitations or risk incomplete repairs. The engine itself isn't weak, but the complexity surrounding it makes repairs extremely risky. If one thing is fixed incorrectly, the truck throws more codes. If something is programmed wrong, it won't run properly. And if emissions components act up again, which they often do, customers return unhappy, even if the mechanic fixed the original issue. That's why so many shops say no to the 2.8-liter Duramax. The repairs are slow, the systems are fragile, the electronics are picky, and the risk of repeat issues is sky-high. For a shop that values time and predictability, these trucks are simply not worth the hassle. Number 2. Ford F-150, 3.5-liter EcoBoost, early years. The 3.5-liter EcoBoost helped redefine the half-ton market with big power and strong towing numbers. But the early versions of this engine came with a laundry list of problems that mechanics still dread today. It's not that the engine is weak, it's that its flaws are buried deep inside the design, and fixing them requires time, patience, and tools that many independent shops don't want to invest in. When these issues show up, mechanics know they're in for a long, painful job. One of the biggest nightmares is the timing chain stretch problem. The early EcoBoost engines were notorious for chains that stretched prematurely, causing a rattling noise on cold starts and eventually triggering cam timing errors. Fixing this requires tearing deep into the front of the engine, often removing accessories, the intake, the turbo plumbing, and multiple covers. It's a long, tedious process where one mistake can lead to catastrophic engine failure. A shop can lose an entire day, sometimes two, just performing this job. Then there are the cam phaser issues, which became so common that Ford eventually redesigned them. Early phasers would rattle, lock up, or throw timing codes. Replacing them means opening the engine again, aligning timing components precisely, and hoping nothing else inside is worn. For mechanics, it's a risky repair that's both time-consuming and stressful. Another headache is the turbo condensation issue. The EcoBoost's intercooler could collect moisture during humid conditions, leading to misfires, stuttering, or full loss of power during acceleration. Some drivers described it as the truck choking mid-drive. Diagnosing this is frustrating because the symptoms can appear randomly. Shops hate intermittent problems. They're the hardest to replicate, explain, and fix. The turbochargers themselves also add complexity. Each turbo sits in a tight, heat-packed area, meaning parts like wastegate actuators, boost sensors, and lines are prone to rust and failure. Replacing a turbo is not a quick job. It can turn into hours of wrestling with seized hardware, removing heat shields, and working in cramped spaces. Many independent mechanics simply avoid turbo vehicles unless they specialize in them. Fuel-related issues add yet another layer. The high-pressure fuel pump and injectors are sensitive. The intake valves build carbon due to direct injection, and rough running can require labor-intensive walnut blasting to fix. Again, expensive, time-consuming, and unforgiving. Electrical issues also show up. These trucks have dozens of sensors monitoring boost, timing, cam position, fuel pressure, and more. When one sensor goes bad, the whole engine can run terribly. And diagnosing which sensor is the true culprit requires advanced scanning tools and experience. All of this creates a perfect storm. The repairs are long, the parts are expensive, and the chance of customer frustration is high. Mechanics know that a single EcoBoost repair can take up shop space for an entire day, which means turning away several easier, more profitable jobs. This is why many shops are hesitant or outright refuse to work on early 3.5-liter EcoBoost F-150s. They're powerful, advanced, and impressive on paper. But once the issues begin, the repairs become a maze of timing components, turbo systems, electronics, and diagnostic traps. For many mechanics, it's just not worth the trouble. Number 1. Ram 1500 EcoDiesel, VM Motori Diesel. If there is one modern truck that mechanics avoid more than any other, it's the Ram 1500 EcoDiesel on launch. It sounded like the perfect idea, a fuel-efficient diesel engine for light-duty truck owners. But in reality, the EcoDiesel became one of the most problematic engines ever put into a half-ton truck. Mechanics don't just dislike working on these, they dread them. The combination of engine design flaws, fragile emission systems, and catastrophic failures makes many shops turn these trucks away instantly. The most notorious issue is bearing failure, especially crankshaft and rod bearings. These engines are known for spinning bearings seemingly out of nowhere, even with proper maintenance. When that happens, the engine usually destroys itself in seconds. Mechanics avoid these repairs because once a bearing spins, the entire engine is compromised. Oil passages clog, metal shavings spread everywhere, and the only real fix is a full engine replacement. No independent shop wants to break that kind of news or take on that level of liability. Another major problem is the oil cooler, which sits in a cramped area and loves to crack internally. When it fails, coolant and oil mix, creating the dreaded milkshake that quickly ruins the engine. The repair is extremely time-consuming, and even after replacing the cooler, there's no guarantee the engine hasn't suffered irreversible damage. Mechanics know this risk all too well. Then there's the EGR cooler, arguably the EcoDiesel's most infamous failure point. These coolers crack internally, letting coolant enter the intake and cylinders. This can cause white smoke, hydrolocking, or full engine failure. In fact, this issue became so widespread that it led to a massive recall. Shops often refuse to touch these trucks because fixing the EGR cooler requires deep disassembly and still doesn't guarantee safety. Another failure could be right around the corner. The DPF and DEF systems add even more misery. The DPF clogs easily, especially for drivers who don't do long highway trips. When it clogs, the truck derates, throws codes, and often requires expensive replacement. DEF system heaters, pumps, and sensors fail constantly. Mechanics don't want to explain to owners why a diesel truck needs thousands of dollars in emissions repairs just to move normally again. Even simple access is awful. The EcoDiesel engine bay is cramped, the layout is awkward, and many parts require partial disassembly of unrelated components just to reach them. Changing something as basic as a thermostat or a sensor can turn into a 2 or 3 hour job. Multiply that by the engine's complexity, and it becomes clear why shops dislike these trucks. And just like the 2.8-liter Duramax, the EcoDiesel requires dealer-level tools for many repairs. Injectors need coating, emissions components require resets, and certain tests can only be performed with factory software. Independent shops that don't specialize in diesels simply cannot take the risk of an incomplete repair. But the biggest fear mechanics have? Repeat failures. They fix the EGR cooler, then the oil cooler fails. They fix the oil cooler, then the bearings spin. They fix the bearings, and the emission system goes into meltdown. It's a chain reaction of expensive, high-risk issues that can happen randomly and with no warning. That combination, unpredictability, catastrophic failures, and extremely labor-heavy repairs, is why mechanics often refuse Ram EcoDiesel trucks the moment they see one pull into the lot. Some trucks are tough, some are dependable, and some, well, even mechanics don't want them anywhere near their shop. These models earned their reputation the hard way, through endless failures, expensive repairs, terrible engineering choices, and designs that turn simple fixes into day-long battles. If your truck didn't make this list, consider that a win. And if it did, now you know why so many shops say "no thanks" the moment they see it roll in. Thanks for watching, and stay tuned for more.